Just a couple things as we get started. First of all, you may notice the background looks different when you first log in. Um, this morning, myself and the lab assistants, mostly the lab assistants, we now have OS X Yosemite on there, which is the newest operating system. And then I had to go to lunch because it took so long. I didn't realize it was over 5 gig, the operating system. And while I was at lunch, they installed Xcode 6.1 on the machines. The only problem that I'm having right now is I successfully put Yosemite on the machine that I use, and I'm trying to update my Xcode, and it keeps asking me. I had to create another Apple ID because the one that I had, no matter what I put in, even though I knew I had the right password, it wouldn't take it anyway. So I created myself a new Apple ID called Don't Forget This SOB. All right, and was able to do everything with that. The only problem is now when I go and I'm trying to update when I'm trying to update Xcode, it's reverting back to my former Apple ID, of which it won't take any password that I put in. So it's not letting me do any upgrading of Xcode. So I got to fix that. All right, so I'm going to just go for a little bit, and we'll start to go through this handout. If you don't have it with you, don't worry about it, okay? Really. It's 463 pages, and you may have noticed over the weekend I read the first 153 pages, just about the first third of it. And some of the pages, if you look at it, they didn't print real well. Some of it still got cut off a little bit. I don't think it's really going to matter, all right? And you do have the PDF copy also if you want it. The first 20 or so pages of this handout give you a swift tour. What I recommend is as soon as you get to something you've never heard of before, just go on. Because the rest of this handout is all about this stuff. The first thing to tell you is if you take a look on the screen right now, that right here, that you can see right there in blue, that's an entire Hello World program in Swift. That's an entire program. Couple things to note. Print line. Sound familiar? Like Java, system.out.println. Same kind of an idea. Hello World in double quotes. You don't have to put semicolons on the end. You can, but you don't have to. The only time it's mandatory that you put semicolons on is if you're combining more than one line on the same line. So if I want to say x equal 1, y equal 1 or something like that, then I'd have to say x equal 1, semicolon, y equal 1. If you put all your code on separate lines, as you should do, you don't need semicolons. All right? So first thing, might look a little funky here, but just so you see this. You use var with variables, the word var. Does that sound familiar? Sounds very JavaScript-ish to me. So again, there are some combinations here of stuff that you've heard in other languages. Again, to me it just looks weird to say var my variable equal 42 with no semicolon on the end. You still can put them on the end, you just don't need to. Let, that's how you create a constant in here. Now I wish that the author would have shown my constant in all uppercase, but they didn't, which is fine. You don't have to make them uppercase in here just like you don't in any other language. The point is, you also can do this, just so you know. You can, for just a second, everything you see in blue there, pretend it's not there. You can just say let my constant. You can do that without giving it a value. But before you use it, you must give it a value. Does that make sense? So I might create a constant that would be called something like number of students in this class, or number of people who are interested in taking this course. And then I could have some kind of programmatic statement where I would count the number, then I could set the constant accordingly. All right? So again, var for variables, and let for constants. If you want to, what happens here, just so you know, do you also notice something that might look a little funny here? Those are both integers. There. What's missing? Int. Because what happens is Swift uses something that's basically called inference, where it infers the type of variable you're using based on what you assign to it. Does that make sense? If you want to, you can still do this. You can still use var or let, and here's an example right here. And don't worry that it says explicit double and implicit double. All they're trying to show you is you could call it anything you want. But if you want to explicitly give the variable type, then what you say is either let or var followed by the name of the variable or the name of the constant, colon, space, followed by the type. And they're weird with their syntax here. They want there to be a space between that colon and the variable type. All right? Again, variables are never explicitly converted to another type. If you need to convert them, you do this. That, to me, looks a little weird. So notice what we've done. The system knows, because this variable is in double quotes, it knows it's a string. The system knows that this variable is an integer because we gave it an integer value. When we want to concatenate the two, we use the plus sign. And there's no toString in here. In here. All right? So you literally say string with. So in other words, it's like, even though it doesn't say this here, it's like you're doing a cast right there. Does that make sense to people? So some of the syntax, when you start looking at it, it looks a little goofy. You're like, geez, I've never done anything exactly like that before. Not only that, whenever you've done this and you've cast it, it's always been the type of variable that's in the parentheses, not the variable name. And if you don't like doing it like that, look at this. I'm not saying you're going to like that either. So we've created two variables here, one named apples, one named oranges. And we want to say I have 3 apples here. So notice how you do it. You use a backslash, then you put the name of the variable inside of parentheses. And that will literally print out I have 3 apples. This one will print out I have 8 pieces of fruit. It makes sense when you think about it, but it's goofy when you look at it because it's not the way we've done things in the past. All right? One thing about Objective-C that's different from Swift, you don't have to write this down, but please listen to this. In Swift, all arrays, every member of an array has to be the same type of data. Did you hear that? So notice we have in here, they call it shopping list, and what we have, it's kind of a weird shopping list when you look at it, but what you have in here is a shopping list of strings. So you couldn't just stick an integer in there or a Boolean in there. Does that make sense? It can only hold strings. When you work with NSArray and NSMutable array in Objective-C, those arrays can hold different types of values. You can have an array that has different types of variables. That you can't do that here. Notice how you create, yeah. Yes. Yes. That'll replace, no, it'll replace water. Remember, they're zero based. Notice how you create an empty array, or a way of creating an empty array. Let empty array equal string bracket bracket paren paren. I don't know about you, but again, to me that looks weird. And the other one's a dictionary. If you remember dictionaries, I mentioned those to you. We looked at them a real little bit, all right, earlier. But a dictionary is a key and a value. So in other words, this dictionary is going to hold things. The key will be a string and the value will be a float. So for instance, if I started to fill up that dictionary, I could put in there Mark's salary, 50,000, Stefan's salary, 60,000, or maybe vice versa, etc. That kind of thing. All right? And again, they talk about this inference. So notice it says here, you can even do this. It says, for example, when you set a new value for a variable and pass it to an argument or a function, there's a lot of ways that you can, for lack of better words, cheat in here. If you get a chance before next class, try to read the first umpteen pages, however many you can get through. Like I said, I'm on about page 155. They don't even get into talking about classes until that page. That's right where I am right now. All right. Some of this stuff is going to look very different, except, okay, what's missing from here? What's missing in the if? What's missing in the for? Parentheses. You don't need them anymore, but you can use them if you want to. So what do we have here? We've got an array of scores. It'll be inferred that these are integers. So that's scores sub, individual scores sub 0, individual scores sub 1, individual scores sub 2, individual scores sub 3, and individual scores sub 4. All right? So var team score for score in individual scores. If the score is greater than 50, you add 3 to the team score. Well, that'll be 3, 6, 9 when you get done. Otherwise, you'll add 1 to it. So you would add 1 more, I guess, for that one and for that one. Does that make sense? I mean, they're still if statements. You still use them the same way. They just look a little bit different. That's all. Notice this. This is, depending on your point of view, this is either really cool or really not cool. All right? In an if statement, the conditional must be a Boolean expression. I mean, it's a big deal. Well, what's the difference between those two? I'm not talking about the equal sign. What's the difference between those two? That's a Boolean test. You're right, that's attempting to assign y to x. That's not going to be legal anymore. That actually will be flagged as an error in Swift because the only thing that you can have after an if is a Boolean condition. That's not a Boolean condition. All right. Again, it might not seem like a big thing, but somebody is dictated and said, well, then we'll have less errors that way if we do it like that. Notice you can use if and let together to work with values that might be missing. These values are represented as optional. And you're going to have to read this a few times. Because I was sitting there reading it, and I was like, huh? Okay. That's what that question mark there means. That means it may or may not be known. All right? Not only that, if you're sure that it's known, instead of using a question mark, you use an exclamation point. You're going to see this again as we go on in here. That's why I said, if this is where it started to break down. When you read this, it's like, huh? They go over it several pages, and they give several examples later on in here. But I'm just going through the stuff that they went through at the beginning. All right. Here's a switch. I think we talked about this last time. If you notice, no break statement. So not only that, when you do a case, if you do a case in the C language, what goes in here must be either a number, an integer, a whole number, or it must be a character. Now it can be strings. So let's assume, for example, that it's cucumber. All right. So let's just assume that vegetable is cucumber. I see that it's red pepper, but let's pretend it's cucumber. Is it celery? No. Is it okay, yes. So it does this. That would make a good tea sandwich, and it skips all the rest. It just jumps out. That's why you don't need the break anymore. And also because I just want you to see this, it just looks a little funky. See that case cucumber, comma, watercress. We'll talk more about that when we get a little bit later on in here. Right. You can use 4 in, and you could have used 4 in Objective-C also. Again, I don't even want to say any more about this. There's a 4 in within a 4 in. Okay. While loop. It should look familiar. Again, there's where it cut out a little bit. That should be the do while right there. All right. But that should look pretty familiar to you. Other than the fact that, again, it's not in parentheses. Doesn't look that different, and no semicolon. Okay. Now let's talk about this. Don't know if it'll let me copy or not. Let's see. And it's going to look a little weird, but just bear with me for a second, because I want to show you something else that's in here. All right. Notice that there are 2 dots in here. I'm going to put another dot in there, because there's a difference between this and this. Well, yeah, one's got 3 dots and one's, yeah, but there's a difference between them. This says include 0, 1, 2, and 3. Did you hear me? All of them. This says include 0, 1, and 2. In other words, go up to. So this is like less than, greater than or equal to 0 and less than or equal to 3. This is greater or equal to 0 and less than 3. You go, my God, it's just confusing as hell. Do I have to do it that way? No. But they're meant to be shortcut operators. They're range operators. All right? Yeah. Input basically anything in there you want. Yeah. And I don't know, I think that just about all of you, maybe I'm wrong, is there anybody in here that when you took the .NET programming class that you had VB.NET instead of C#? Okay. Okay, well, and it's fine. And I don't know if you had me for it or if you had Denny for it, but in C#, when you do you say, what? Basically, it is a switch on X. Case 7, you do some stuff, break. Case 3, do some stuff, break. Default, do some stuff and break and get out. Well, the reason I'm showing you that is what you can do in VB.NET. You might have remembered this, you may or may not have. It goes back to what you just asked, Mike. In VB.NET, you can say case 57 to 63. You can do that in VB.NET. You can't do that in C#. You can do that in Swift. You can put ranges in your case statements. All right. I don't remember if it's 2 or dot dot. We're going to see it, but it's something like that. Yeah. Yeah, it's like I said, it's just, this actually would be a really cool language if it was the first language you learned. All right, because it's quirky and you're used to things, because you learn JavaScript, which is sort of unconventional, but lets you do some things and doesn't let you do other things. Then you learn some languages that are really highly regimented, like C# and like Java. But this one is regimented in some ways, and in some ways it's not. All right. All right. Notice functions. Func. What this says is it's a function. Its name is greet. It has 2 parameters. One that's a string that'll be referred to in here as name. One that's a string that'll be referred to in here as day. And notice the minus sign with the greater than sign in string. That means that returns a string. Again, it's just a different syntax. So note in there, what that'll say, for example, let's say you passed in Mark and Monday. That's gonna return hello Mark, today is Monday. But what's weird about this language, you're gonna see this in just a couple minutes. In fact, you see it on the bottom of the page. It's the first time I've heard of this in language. Okay, what's the magic rule I always told you about functions? Functions can return how many values? 0 or 1. Until this language. This language allows you to work with a tuple. That means you can return as many things as you want in a function. You can return 50 different things if you want to. That's new. That's kind of what you're doing, all right, to be honest with you, but it calls it a tuple instead of calling it an array. So notice right here, function get gas prices, double, 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 return. Three amounts. Yeah. Functions can use a variable number of arguments. Notice again, that's 3 dots. That just means that what's cool about this is and I'll show you this in a minute. Let me move it up a little. I can call this routine now, and I could pass it in 5 different numbers, and it's going to add them up and return the sum. Then I can call it again and pass it in 3 numbers. I can use the same function and give it different numbers of inputs. Does that make sense? Yeah. If you want to have a variable number that you're passing in, that just means that, if what that's saying is basically you're going to be passing in an array of numbers, and it can be a variable number. So you can call it. You can call it with 10 different arrays, each that has a different number of numbers in it. What they're doing is they're making functions more variable. All right, and just wait until we get into what's next, which is closures, because the example they give in here, it's really a good example, but it drives you nuts. You have to read it a couple times. This is so JavaScript-like, because like JavaScript, you can now use a function in Swift as though it's a variable. So a function name can appear on the left-hand side of an equal sign. All right. You can nest functions. And notice we've got a function called add in here that's inside of a function called return 15. And add, the inner function, has total access to anything defined in the outer function. And if you look at that and you go, that's just really weird, then I wouldn't do it for a while. You could still do it as 2 functions. It would depend on your logic. And literally, if you're calling out to a lot of different functions, every time you call out to a function, it's going to take some time. If I'm writing a real-time sensitive type of program where every millisecond counts, by nesting functions like this, I might be able to substantially cut down on the amount of time it takes. Other than that, I can't see a lot of value to it. Functions are a data type. Again, functions can return another function as a value. And again, you're going to see this later on, so if it doesn't make a boatload of sense right now, you're going to see it again later on. Some of the stuff that's in here, we're going to be able to blow by, because they're like, this is an if statement. And if you've got one alternative, you can use the word else. If you've got several alternatives, you can use else if. You can put an else on the end, but you don't have to. So why should we spend time on that? Yeah. That's what they decided to use. That's the return type. I mean, I didn't write the language, so I can't really tell you. All right. Booleans are type bool, capital B, little OOL. Can only have true or false. Some programming languages allow Boolean variables to have true, false, or null. This isn't one of them. True or false, that's it. Yeah, that example they give is just confusing. I'm not even going to go over that. Objects and classes. Use class followed by the class's name to create a class. Well, that shouldn't look, this shouldn't look bad to you. All right, so what is its class? What's its name? Shape. What does it have? Well, it has a variable in it called number of sides, and it has a function in it called simple description. So right now, basically, it has the ability that it has no sides, and if you call simple description, it'll say a shape with 0 sides. That's it. That's all that's in it right now. Kind of a silly class, but they're just trying to show you the kind of stuff that you'd put in it. Then outside of there, this is how you instantiate it. Var shape equals shape. Yeah, because that's right there. That's the class name. Shape dot number of sides. Now we're changing it from its default of 0 to 7. And now when we say simple description, it should say a shape with 7 sides. Well, that's right here. That's where you're going to be calling the statement that's going to go into it. It's not that different from what we did in Java. You know, when we'd set up getters and setters, for example. It says this version of the shape class is missing something important, an initializer to set up the class when the instance is created. Use init to create one. So that's like a constructor. You don't use the word this in here, you use the word self. Not only is there an init, notice there is a dinit. Just like we really haven't talked about it, but Java not only has a constructor, it has a destructor. And the reason I never told you about Java destructors is you can call a Java destructor, but you don't have control over when it actually gets called. Even when you call it, it doesn't mean it'll be called right there. In Java, typically, what you do is, instead of having a destructor function, you create another function if you want certain things to happen when you're all done, and you call that function finalize. And usually, because finalize, you can have some control over when it gets called. All right. Again, sound familiar? In addition to simple properties that are stored, properties can have getters and setters. And we're going to be going through this. All right, it will be easier to read when we go through it. And they go through a typical triangle type of thing. Again, I don't want to even talk about that. Members of classes have one important difference from functions. Notice this, parameter names and functions are used only within the function, but parameter names and methods are also used when you call it. By default, a method has the same name for its parameters when you call it as the method itself does. Unless you want to change it, which you can do too, but then you've got to do this. All right, you basically have got to come in and give it another name. Really, I mean, so much of this stuff in here is like, what? That's why I think it's going to be important when we start doing this that we create a few of these as a class. All right. Hopefully then it'll make a little bit more sense. You can have enums, but enums don't work the same way in here that they do in C and in Objective-C and in C#, etc. In that case, if you have an enum, all right, and if you do something like this, case ace equal 1, 2, 3, 4, 5, etc. All this stuff. All right. So you might say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That doesn't make sense. Why would king have a value of 13? King doesn't have any special value. The only value we've given right now is ace that's got a value of 1. When you use enums, you can look at it in one of two ways. Either they're less powerful than what we've been using, or the way I look at it is they're more powerful because you can make anything an enum. And an enum is just a user-defined data type. But then you can figure out the value of each thing in the enum. All right. you can use almost anything inside of an enumeration. Yeah, I don't know why they always feel like they have to use cards. Every book I've ever used. This is where it really gets. All right. You can create protocols and you can create extensions. I'm just going to hold off on those until we get to that point in the book, because it's about as hard to understand as it is in this language. And create generics. What the heck is a generic? A generic means it's something that may not be known until the time the program's running. So this, what's in here, might be a string, and then later it might be something else. That kind of thing. All right. And again, we'll talk about that later on. Now that was it. That's the first 20 or so pages. Then they start to go into each one of these things separately. So I'm going to go in and I'm going to spend, I'll stop at around 350 or so. All right, and I don't want to read a bit from this book to you. You may or may not have noticed the thing is hyperlinked up the wazoo. All right, so you should be able to go in there, and I'm looking right now, for some reason it's supposed to be hyperlinked, but it looks like it's just underlined. I should be able to click on that, and I'm not sure why I can't. All right. So the first thing they do is, again, they talk about constants and variables. We don't have to talk about this stuff because you know what a constant is. You know what a variable is. Again, var for variables, let for constants. Notice you can do this. Why you'd want to do this, I don't understand. You can either put commas between there or you can put semicolons in between there. And actually in this case I think it would want there to be commas, but I could say var x equals 0.0 semicolon var y equals 0.0 semicolon var z equals 0.0. All right, I don't know exactly what that buys you putting it on one line as opposed to several lines, but evidently the author felt the need to show you that. So this is what I mentioned to you before. So here we're creating a string variable called welcome message. So it's, if you want to explicitly declare the type of variable, it's var followed by the name of the variable, followed by a colon, followed by a space, followed by the variable type. All right. You can use Unicode characters. So now if Stefan wants to go and find out what those Serbian Unicode characters are, he can go and write Serbian code. All right. The last count that I heard, there are over 100,000 different characters in the Unicode character set. That's basically every language that exists right now. And there's still some that aren't being used yet, so you probably could go in and create your own language. You might have. Now they show you this again. Of course, since it's a variable, var friendly welcome equals hello, friendly welcome equal bonjour. So you changed it. But if you say let, meaning it's a constant, and you say let language name equals Swift, then later you say language name equals Swift plus plus, you get an error. Just like you'd get an error in any other language when you try to change the value of a constant. All right, nothing new there. You can use print line. And you can use print line, and you can put in there either a variable or a constant. You already saw that if you want to print out the value of something, this is called interpolation. They ripped that word off from Perl. So again, this would say the current value of friendly welcome is bonjour because that's what we set it to right there. Right there. Comments, no change there. Slash slash for a single comment, line comment, slash star, and ending with a star slash for a multi-line comment. So nothing there. Semicolons, we already talked about these. And there's an example where you're doing a let and then you're doing a print line. Okay. Most of this stuff we can kind of whip through. What the author says here is, unless you know and you have a reason, You can use 8-bit integers, 16-bit integers, 32-bit integers, or 64-bit integers. And most of the time, guess what? It doesn't make a difference which one you use, so you just will use int. Period. Because it's much easier. They're also unsigned. All right. So an int, I believe, it says on a 32-bit platform, an int can store 2 billion plus to negative 2 billion plus. So if you used unsigned int there, instead of being negative 2 billion to positive 2 billion, it would be 0 to 4 billion something. Okay? Floating point, you're only guaranteed with a regular float. You're guaranteed 6 decimal places of precision after the decimal place. And I think it's with a double, it's 15. Okay. Now notice, because you're going to see this all over the place in Swift documentation. Swift is a type-safe language. They don't let you do things that JavaScript lets you do, where you can sit there and I create a variable called age. I say var age equal 21. And then in the next line I say age equal hello, for example. You can't do that. As soon as you say var age equal 21 in Swift, the system says, oh, you put an integer in there, so that's got to be of type int. Or you could have said var age colon space int, all right, and then equal 21 to explicitly put it in. But if, as it says, if it expects a string, you can't pass it an int by mistake, or vice versa. And you get some weird stuff. Look at this. It says right here, it is possible that if you try to do this, right there, it may not work. All right? Because the system really wants to add together things that are of the same type. It wants to add together a float and a float, or a double and a double, not an int and a float like you see right here. You're going to see another example of this later, so just let me hold off until you do. You can print stuff now in binary, so all of those of you who always wanted to print out your stuff in zeros and ones, you want to make your code look like machine language, you now can do that. Yeah. So you can print in decimal, binary, octal, or hex. As it says, use the int type if you don't know. It should handle everything that you ever want to do. That's why, because the range is different for each type, and you just don't have to worry about it if you just use int. As it says, that's the one I wanted to show you. See, notice let 3 equal 3. All right, so that's the number 3. Let 0.14159 equals 0.14159. If you didn't say that double before it, you'd get an error message. The good news is, if you screw up, you're going to know real fast, because once we get in and we start working with these playgrounds, if you put in something that's illegal, instead of showing you the answer on the right-hand side, it's going to show you an error message. All right. Type aliases. All right, it's like a type def. So if I do this, type alias audio sample equals uint16, that means everywhere now that I create a new variable, or I start using something with this, this is the same thing as saying var max amplitude found equals uint16.min. That makes sense? It literally is an alias. But you don't go an alias like float for int. Don't do something like that. But for example, instead of int, let's say that, or here's a better example. I could come in here and say something like this. I could say type def married equals bool. And now married, would have true or false. It might make it a little bit easier. Sometimes you can make your code a little bit more readable, all right, by working with these aliases. Notice in here that they talk about this. This works because that's true or false. But again, it says that will not compile. That line right that you see right here, this will not compile. So you can't use the shortcut right there. You have to say if I equal 1 right there. These, again, you're going to see these several times. These are those tuples. As it says, group multiple values into a single compound value. And notice, they don't have to be the same type. So in this tuple, we've got a number and we've got a string. Well, what does that mean? Well, that means that there's two components in that tuple. There is an integer called 404, and there is a string called not found. Then what you can do if you need to later is you can decompose the tuple to grab the individual pieces of data as you need them. Okay? And that's what they're showing you right here. And if that doesn't totally make sense, you're going to have to, believe me, I wouldn't expect that you'd go over all this and you'd go, oh, that totally makes sense. Yeah, that makes sense. Yeah, that makes sense. Yeah, that makes sense. No. Notice, tuples are particularly useful as the return values for functions. Because, again, you can return multiple values. All right? Optionals, I mentioned this to you before. Now notice this. You use optionals in situations where a value may be absent. So it might not be known. An optional says, okay, if there is a value, basically you're going to use it. But if there isn't, protect yourself. Okay? In other words, you know, for example, in JavaScript, if you did this, if I said var age, just like that, if I said var age and I didn't give it a value and I tried to print out the value of age, it would come back and say undefined. All right, that's kind of what you're trying to account for here. It's something that may or may not be known. And notice what it says. The concept of optionals doesn't exist in C, doesn't exist in Objective-C. The nearest thing you have in Objective-C is nil, but nil only works for objects. You can use optionals for anything, simple data types, objects, anything you want. So it says, the example below uses the toInt method to try to convert a string to an int. All right? So let possible number equal 1, 2, 3. Let converted number equal possible number dot toInt. And that'll work. All right, it says converted number is inferred to be of type int question mark. Why? Because what if I put hello in there? What's going to happen? It's not going to be able to convert it, right? Because it won't know what it is. But if you tried doing that in C or in Objective-C, you'd get an error message. Here you won't. Basically, you're saying it's just you can't do it. When you're working with this stuff, as it says, you can use an if statement to see if there's something in it. So you can see if there's a value. This is a shortcut. That's basically saying if there is a numeric value in there, then you can print it out. Otherwise, you get an error. So again, if I tried to do this right here and I put let possible number equal hello, that would fail. So it would come down and it would say hello cannot be converted to an integer. Says let you use optional binding to find out whether an option contains a value, and if so, you can assign it to something. Okay? So the same stuff they're doing here that we talked about before. But notice you can do this. Also notice if let, that is an assignment statement, so there is a single equal sign there. If this succeeds, so again, if I put 23 in there like they did before, now it'll say um, 23 in double quotes has the integer value of 23. But if I put hello in there, this will fail, so it'll come out and it'll say hello cannot be converted to an integer. All right, they keep going on and on and on with different stuff that you can do here. Remember, this is a manual, and this is a manual from the people who wrote the language. It's a little dry, and they're trying to give you a lot in a little bit of time. It says you set an optional value to a valueless state by setting it equal to nil. Right there. So right now, what we're saying is we want to set server response code equal to 404. Here, we're saying we don't know what its value is. Since it's a number, we don't say 0 because 0 is a valid number. You can't say something non-numeric or you'd get an error message, but you can say nil, which means unknown. And you can do the same kind of stuff in here. Make the same kind of checks. Now notice with this, if you're sure that possible string holds a number, you can put an exclamation point in it. So the question mark means may or may not happen. The exclamation point means for sure it's going to happen. The problem is if you use that exclamation point and there's not a valid value in there, the program does blow up. All right. And again, that's all mentioned in here. Last thing, they talk about assertions. You know what an assertion is? Basically, here, let's just show you an example. All right. Let age equal -3. Assert age greater than or equal to 0. A person's age cannot be less than or equal less than 0. So what it's doing right here is there you're doing an assignment. The assert says make a test. Is age greater than or equal to 0? If it is, let it keep going. If this test right here fails, then that is going to print out on the screen, out in your debug area. That can be really nice to use assertions when you're testing, all right, to make sure that your code is working the way that you want it to work. If you don't want to give it any message, as it says, you can just do that. It makes it hard because you don't know exactly. Typically, you want a message in there to fire so you know what's going on. So the author says, when do you use these? And this, like I said, this is the last thing we're going to talk about. All right, we'll pick it up on basic operators next time. But he says, when to use assertions. If you've got an index in an array that's out of range. All right, a value is passed to the function, but an invalid value means the function cannot fulfill its task. So again, what if I'm expecting, same kind of thing, like they just mentioned there with age. What if I'm doing something that I'm having you pass in 2 ages, so I want to tell the difference in ages between 2 different people? I could check to see if either one or both of those values were either, for example, less than 0 or maybe greater than 125. And if either one of those things were true, I could have an assertion that said, that just printed out an error message because there's no use in going on, that kind of thing. All right. Or an optional value is nil, but you try using it as though it's not nil. So again, that's the beginning. You're going to see it. We'll pick it up next time right here. Basic operators. Some of this we'll go through quickly because it's addition, subtraction, multiplication, division, modulo. The symbols are the same. All right, so it's a lot of the same stuff that you've already seen. So we should be able to buzz through some of this stuff kind of quickly. I'd like to get to a certain point, ideally, like I said, about where I am right now, maybe around those first 150 pages or so, and then go in and write a couple programs as a class. All right? When will we be there? I don't know. Okay, we went through 50 pages right now.